All right, so continuing from where we left off last time, we're looking at the velocity, and we're determining the velocity by looking at these graphs between any two times. So if you look at, for example, from going from point A to point E, you can see that your displacement from point A to point E is actually minus 67 meters. Now there's a little typo here. Your final position is negative 37 meters minus your initial position is positive 30. It should be a positive. Gives you a displacement of negative 67 meters from A to E in a time of 40 seconds. So your average velocity, represented by this slope from A to E, is going to be negative 67 meters in 40 seconds, or negative 1.7 meter per second. Now, that is an average velocity. As we said before, we start off moving in the positive direction, slowing down, then turn around, speed up in the negative direction, and actually start to slow down a little bit before we get to point E. But our average for that entire motion, represented by this slope from point A to E, is negative 1.7 meter per second. However, sometimes we want to know not just the average between two discrete times. We want to know the instantaneous velocity. What does instantaneous velocity mean? Instantaneous velocity is how fast you're going at a given instant in time. So the speed that's measured, the rate that's measured on your speedometer is your instantaneous speed, and then if you added the direction you were traveling, that would give you the instantaneous velocity. The speedometer tells you how fast am I going right now. So how do we determine that? Well, in order to determine that, we can basically take a really small time interval, because the smaller the time interval, the closer you get to an instantaneous velocity, an instantaneous rate right at that time. And to do this exactly, you can take the limit as the time goes to zero of your displacement divided by your time, and that's a calculus thing called you take the derivative of the position as a function of time position as a function of time. So we'll go into that in more detail together in class, but an example here is what you can do is you can look at the position of a car at specific instance in time, and what you can see is that from 1 to 3 seconds, it took, you went 47.5 meters, and your average velocity for that time was 23.8 meters. But if you take a smaller time interval from 1 to 2 seconds, you can get a more closer to a rate that is at an instant in time. So what they're doing here is they're reducing the amount of time between a time interval. And so from, for example, when you go from 1.00 to 1.01 seconds, it's a very small time interval, and that very small displacement will give you an average velocity from 1 second to 1.01 seconds that is very close to the instantaneous velocity at around 1 second. And so here what we're doing is we're getting an average velocity over a time interval, over a 2-second time interval, and that is, it's going to be an average for a fairly large period of time. But if you take a very small time interval, for example, from 1 to 1.01 seconds, you're actually getting a specific instantaneous rate. Now, there's other techniques by which we can do this, and we'll talk about those more in class. Okay? So basically, a graphical way of determining the instantaneous velocity from a position time graph is if you take a point on the graph, you can take a tangent line to that point, which is basically representing the slope right at that time, and that is basically telling you an instantaneous velocity at that time. So because the slope of a position time graph tells you what the velocity is, the slope of a tangent line gives you the velocity right at the point that the tangent line intersects. Okay. So, anything else? Yes, the slope of the line tangent to the position versus time curve at a given time is defined to be the instantaneous velocity. So let's see if we can find a tangent line here. So the green line right there is a tangent. Let me see if I can get this. Yeah, there's a tangent line right around this point right there. So that green slope is basically giving you approximately the rate at this moment in time, while these blue lines are basically average velocities between the points, 2 points in question. So the average velocity between here and here is given by the slope of the blue line. The average velocity between here and here is given by the slope of this other blue line. The average velocity between here and here is given by this green slope. And the average velocity from here to here is given by this, which is starting to become very close to the instantaneous velocity somewhere right in this region right there. So take the slope of the tangent line, that will give you an instantaneous velocity off of a position time graph. Okay? So object 1, what's object 1 and object 2? I don't know what that is. Instantaneous velocity of object 1. I'm not sure what that's referring to. Sorry, guys. We'll come back to that. But the instantaneous velocity at this point right here is, I guess that's what they're calling object 1, is about 15 meters per second if you take the slope of that tangent line. And I'm not sure where object 2 is. Okay? So we'll talk about some of this in more detail in class. But for now, let's just... That's the idea of the distinction between an average velocity and an instantaneous velocity, and we'll continue to work on that. All right, so let me end this. I'm done. I'm just going to shut this off now. Let's see.